What is Hyperledger Fabric? Hyperledger Fabric is a product led by IBM. It is a plug-and-play implementation by which IBM eases developers to develop high-scale blockchain applications with permissions that are flexible. To sum it up, it is an open-sourced framework implementation hosted under Hyperledger project. Hyperledger Fabric was first introduced by IBM as a result of the first hackathon and can sometimes also be called as IBM's Fabric. Fabric usually incorporates many things that are not present in other blockchains. Unlike Ethereum, Fabric doesn't require a built-in cryptocurrency. Although it's possible to develop digital tokens similar to Ethereum with chain code, but this would require a significant investment of development resources such as plug-and-play. This feature of Hyperledger sets it apart from Bitcoin and Ethereum. The Hyperledger Fabric framework is implemented in Go and can be used to set up public and private blockchains. It is made for enabling consortium blockchains with flexible degree of permissions. Fabric entirely relies on a smart contract system called chain code, and every peer of the network runs in Docker container. It allows components like consensus and memberships for plug-and-play. Hyperledger Fabric is designed to allow network starters to choose a consensus mechanism that represents the relationships existing between peers. Also, there is a spectrum of needs, from networks which are highly structured in their relationships to those that are more peer-to-peer. Another component is memberships, which aims to offer an abstraction of a membership operation architecture. In particular, membership abstracts away all cryptographic mechanisms and protocols behind issuing, validating certificates, and user authentication. One or more MSP can govern a Hyperledger Fabric network. It also leverages container technology to host smart contracts, which is called chain code, and that comprises the business logic for the applications. Hyperledger Fabric Chain Tool is a utility to assist in various phases of Hyperledger Fabric chain code development, such as compilation, test, packaging, and deployment. Working with Chain Tool generally involves structuring your chain code project route in a specific way, and then running various subcommands. Some commands, such as build, clean, and package, are used to manage general development activities. Hyperledger Fabric intends to offer many SDKs for a wide variety of programming languages. The first two delivered are the Node.js and Java SDKs. Python, REST, and Go SDKs are to be released in the near future. Chain Tool is a utility which assists in various phases of Fabric chain code development, such as different phases of compilation, testing, and packaging. After that, we can project the interface to our application in a high-level interface definition language using Chain Tool. Once this is done, the Chain Tool will generate chain code stubs and package the chain code for deployment. Chain Tool can provide various benefits over chain code development. For example, it provides a neutral description of application interface, and by description we mean that it does not require any specific programming language for application interface, whether it is written in Go, Node.js, or any other programming language. It will run the chain code without any problem, similar to chain code for deployment. Next is wire-endian neutrality, which means that it can run both big-endian and little-endian, which means it can support both Unix and Windows-based systems. Moreover, built-in field validation means that Hyperledger does not require any external third party for validation. Coming to the forward-backward compatibility management, we don't need a specific version of Hyperledger Fabric to run Chain Tool. Hyperledger supports compatibility with all its versions apart from when certain different functions or API is released. The stubs function dispatch means we can create frames for Hyperledger Fabric. Then the next one is build package management, which means that it provides you a framework to build the Go and Node.js packages in Hyperledger Fabric. And the last one is unified query, signing, hashing, and introspection interface. This means that we do not require to run our SQL queries separately. Instead, we can do it with the help of chain code. Hyperledger supports smart query mechanisms which are simple to call and implement. There are various other technologies under Hyperledger, such as Soramitsu's Iroha. It is a business blockchain framework designed to be simple and easy to incorporate into infrastructural projects requiring a distributed ledger technology. It is a domain-driven C++ design that is simple and modern. This Hyperledger technology focuses on mobile application development and is based on Byzantine fault-tolerant consensus algorithm. The Byzantine fault-tolerant consensus algorithm, in a nutshell, raises a fault where all the peers do not get the same value. Hyperledger Iroha was initially contributed by Soramitsu, NTT, Data, and Kolu. It is pronounced as Iroha. Next, we come to Sawtooth Lake. Sawtooth is a modular platform for building, deploying, and running distributed ledger. It simplifies blockchain application development by separating the core system from the application domain. Developers can mention the rules appropriate for their application, using a language for their choice, without knowing the underlying design of the system. It was contributed mainly by Intel and is also a project under the Hyperledger umbrella. Another technology that we are going to talk about, which comes under the Hyperledger umbrella, is Hyperledger Burrow. This technology is a permissioned blockchain node that executes the smart contract, similar to the Ethereum virtual machine. It is built for multi-chain support, and it is contributed and sponsored by Monax and Intel. This technology of Hyperledger is hosted by Linux Foundation, which brings the deployment model to the blockchain ecosystem on demand as a service. Developers use this technology to reduce the effort required for creating, managing, and terminating blockchains, and can also use it to develop their very own blockchain as a service. This blockchain module is designed to create web applications and can easily invoke, view, deploy, or query block transactions and associated data, network information like name, status, list of nodes, etc., chain codes, and transaction families, as well as any other relevant information stored in the ledger. Indy is a private, secure, and powerful identity which provides the tool, libraries, and reusable components for providing digital identity rooted on the blockchain network. Once Indy gets implemented, the organizations which are centralized identity become in charge of the decision about their privacy and disclosure. After the implementation, it also becomes interoperable across administrative domains, applications, and any other silo. That's it for this session. We will continue other topics in the upcoming session. If you have any queries regarding this session, you can email them to us on hello@blockchain-council.org.